Hello, I'm Dr. Sam Hancock of the Emerald Planet and Emerald Planet TV. We come to you on a week-to-week basis from Washington, D.C. in the United States as we look around the globe in 144 different nations, looking for those 1,000 best practices, the technology, services, and products that are making a difference as we move through the 21st century. And as we have a planet of 9 billion people by 2038 and possibly 12 to 13 billion by the end of this century, how are we going to be able to take care of all these people on planet Earth? And that's what Emerald Planet's all about. We come to you looking at the solutions, the best practices from around the globe as we create the Emerald Planet. Hello, welcome to the Emerald Planet. We're making a difference as we move through the 21st century. And seeing the long-term impacts of climate change. We're glad to have you. Thank you for being with us. Looking around the globe, how do we take care of Mother Earth to accentuate and make even renewed not only the water, which we talk about often on the Emerald Planet TV, but also the soil and the air? And we have someone who really is focused on the soil, but actually to counterbalance and to renew the air and water at the same time. This is really, truly a world phenomenon and expert, Dr. Andrew Harley. He is the president, researcher, and author for the Ascension Soil Company. And we're going to be talking about rejuvenation of land, water, and air quality using biochar. And Andrew, welcome to the Emerald Planet TV.
Great. Thank you. Thank you very much. I look forward to the conversation.
Well, we're glad to have you here. Ascension Soil Company. Why the term Ascension in your name?
Yeah. Look, Sam. It came about actually about almost over 25 years ago now. And when I was beginning, I was finished my academic work. I was kind of, looking at where I wanted to take it, and the concept of ascension, of bringing things to life. And this was really, I was working on very, dead soils, and it came to me. There's the whole concept of bringing soils to life, because the soil's life. A healthy soil is a live soil, and it was really just kind of, just an inspiration. Almost 25 years ago, that was really my my mission, was to improve, not just improve soil quality, but through bringing it to life, not just the mineral components, the nitrogen, phosphorus, potassium, the things that we think about as nutrients, but the importance of the microbial action in that, the living pieces of this that really can sustain life on this planet.
I think that's very important, and I really admire the logo that you have. It's beautiful, but yet it really tells a story in itself. But looking at rejuvenation, why the term rejuvenation, and why are we looking at this balance between land, water, and air for the improvement of the environment?
The concept, well, it's not really a concept. I mean, human life is basically dependent on 6 to 12 inches of veneer around the around the planet. Obviously water resources are important. Obviously the air we breathe is important. But that thin veneer, that soil, the difference between geological processes, in our rocks and the air processes is this biological process that occurs within the soil, and so much happens within this particular very, very thin layer. I mean, as a proportion of our land surface, it's minuscule. But without it, and there are so many things that happen within this soil process, and we can deal with a range of our challenges. A range of our challenges are associated with issues around our soil, and by correcting those soil things, there are so many benefits that we can have, and it's really this cumulative effect. It's not just a one-on-one component. By dealing with this very thin veneer of the soil, we can manage so many different other aspects and challenges. So that's why I'm fascinated about the power that the soil can help us in mitigating challenges, whether they be climate change challenges, water quality challenges, food production challenges. It is all dependent on the soil, and our current kind of engineering approach to managing the soils not necessarily working. We're losing so much, so many soil, so much soil, but not just in terms of volume, but in terms of productivity as well.
Okay, I understand that. And also, we talked about the renewable energy, waste management, all these other issues, but really, soil you think is one of the key. Now, looking at the biochar, I put this up, this image side by side, so we can actually look at all of that. But let's go through this as far as what is actually happening here in the biochar as far as the canopy is concerned, and then everything we really don't see below.
Yeah. Look. So just taking a step back from biochar is a form of carbon, and we in terms of dealing with climate strategies, we talk about carbon sequestration. We talk about having too much carbon in the air. Biochar is just another form of carbon. Carbon is this whole sequence of forms, and we're constantly talking about carbon sequestration. Well, we need to get carbon out of the air. We need to put carbon, in the soil. We need to pump it deep into the into the earth. The real value of carbon is that it does cycle. It is a cycle. It's like water. We don't want to be locking all of our water up into glaciers. We'll get another ice age at that standpoint. And to a degree, the same with carbon. And what biochar does is that in some regards it does store carbon, but it also supports a lot of our life supporting processes that can help. In terms of biochar in the soil, it can increase fertility. It can increase nutrient cycling. It can increase soil structure. The ability for roots to grow into our soils. It can increase water availability. It can store water in these in these regards. So it is, we tend to think of carbon in the soil as a means to release nutrients, but if you're doing it all at once, where's the value? So it's almost has a regulating effect within the soil. In terms of what it does from the atmospheric benefits, it does store carbon. I mean, in some regards, the process does take CO2 out of the air, and it puts us into this form that is very stable and stable in the soil, while it's doing all these other soil components in there as well, and kind of can also support through that process. It can actually become carbon negative through that piece. But some of the recent work since we last spoke is that it can help with a lot of the other atmospheric issues that we're dealing with. It can support methane. We can reduce methane emissions, and we understand that methane release, especially up in the Arctic condition right now, may have potential. May have a lot of impacts on climate change. So its ability to kind of take that out. It's been shown to really support nitrogen cycling, nitrate runoff, all of these other components that can impact water issues, such as in the Great Lakes region of the United States. And it's also being used in large livestock facilities, CAFOs, for example, and it's helping to absorb and reduce odors that are going in there too. So it really has this. It just has this broad effect. I apologize. Just this broad effect on both the soil and the atmosphere. And again, coming back to this the importance of this thin veneer around around our Earth's surface. It's that just that integration. It can do so many things in such a small volume.
Mm-hmm. Yeah, and looking at this now, there's different ways of doing this, different methodologies, processes. Much of what you're doing is that you want to do it naturally, organically, and allow nature to heal itself, but at the same time to increase the nutrients in the soil, which directly relates to air and water quality. So let's quickly go through this chart. We're going to be running out of time very quickly here, Andrew. Let's go through this, and then we'll hit another couple of issues, and then we'll close the session out.
So you look. I'll summarize it very quickly. And this has been the great work that's been done in recently. Is that originally when we were starting to get into biochar, we were thinking that it's biochar. It's this source. It does all these great things. What we've now got is we've developed a library of material that we understand that the different feedstock and the process for creating biochar has very different characteristics. So, for example, if we're looking for water storage, which is something I'm very interested in working in arid zones, I'm interested in finding that material and those conditions that can create a biochar that helps with water storage and water cycling. If we're interested in nutrients and nutrient cycling, then we've got a good idea. In this case, pecans are very, very good at helping with nutrient cycling. And it tends to be produced at a higher temperature. If we're interested in carbon sequestration, we've got a very good idea what material and what process can help with that. And same with water infiltration, root growth. And then microbial processes, again, coming back to the Ascension piece, bringing soils to life. I'm very interested in looking at those sequences, that material that can help on improving a microbial life and bringing our soils to life.
Yeah, this is absolutely an amazing chart, Andrew. This is something new since the last time we chatted, but to have these broad ways to deal with these different issues, similar types of outcomes long term, but really there's different tools in the toolkit to get at these issues and to make sure, again, we're having that soil, water, and air balance. Tell us what we have right here, Andrew, and I'll have one more question, and we have to get out. We're just running out of time.
Yeah, sure. Look, all this is showing is that again, we're getting a really good understanding what material to use and how to produce it to produce different biochar characteristics to depend on what they're working on. A lot of the work that I have been doing is on mineland reclamation, and so I have metal issues. So I'm really looking at those that biochar that has a high surface area that can absorb metals and take it out of the system. So really, this is just a summary slide to show that we're starting to get a really good handle on how best to produce, for want of a better word, a designer biochar for what it is that we need.
It's amazing what a decade will do for you. Last question. You've got about 20 seconds. We have to be quick. What do you see for the growth and expansion of Ascension Soil Company over the next 5, 10, or 15 years?
Really, it is taking these concepts and really implement them at landscape scales, and that's really where we're putting our focus.
So. That's absolutely fantastic. This is Andrew Harley, looking at Ascension Soil Company. Thank you for being with us as we look around the globe to create the Emerald Planet.